Welcome to part 5 of chapter 5, the Lyra Inventory system. In our last video, we talked a little bit about the use of the inventory and storage as two separate inventory buckets. We talked about the 5 basic actions in the inventory system, such as adding an item to storage, removing an item from storage, combining two stacks together, swapping items from one to the other, and then splitting item stacks, which we did not cover in the last video. We really didn't talk about in the last video was the 3 world actions that are also part of this whole system, which is the ability to pick up from the ground, the ability to drop to the ground, and the ability to gather from a node. As we started to look at all 8 of these actions together in our previous design, similar to what I telegraphed in the last video, it was getting complicated with the way we were using the set stat tags. And so we went ahead and re-simplified that and re-architected the way that we handled these actions. So I thought I'd go through those quickly, then jump in, show you basically the solution in action, and then we'll explore the pickup class, which has had significant changes since our last video. So in this video, we're going to cover off the simplification of the use of the fragment set stats. We're going to talk about the refactoring of our gameplay abilities to use a base class so that we're not repeating code across different classes. And we completed our stacking logic with a major rewrite of the interact collect gameplay ability and a redesign of the drop and pickup actor. We still need to get to our split stacks, but we figured we'd get this video out and then maybe put that out as a supplemental. But this should be the last video in the series, and this should complete the inventory section. A couple of things to note. We have had to make 2 very minor code changes in the base content. It just became too complicated to copy those actors and make all the references work. And so on the Lyra Inventory item instance, there is already a function called get item definition. However, it was not blueprint callable. So we went ahead and added a U property to make that blueprint callable. And in the item pickup, we needed to add blueprint read write to our pickup template and item pickup. So those structs are defined in the interface I pickup header file. And those were just adding the blueprint read write tag. They were, I believe, all blueprint read only at the time. And then I'm not sure if we covered this in an earlier video, but we had cloned the Lyra World Collectible, which we've named LyraWorldCollectablePlus. In that, we've added 3 set of capabilities: the ability to activate and deactivate, which is needed for a node, so that once you mine the node, it goes into a deactivated state. We added an on interact, again for nodes, so that as you interact with a node, it will reduce the charges on that node. And then we had to add a set pickup inventory to enable our drops to basically set the pickup quantities, so that when we dropped something and then picked it back up, it would have the same quantity that we dropped. So those functional changes were made in the C++ library. Send me a comment if you want more information on any of those. And then I just highlighted here on the bottom of the screen where you would add the blueprint read write in the U property for those that had to be changed. So let's take a look at the simplification of the set stats fragment. If you remember from our last video, we had defined 2 keys that were the amount or quantity in standard inventory and the quantity in storage inventory. That became just too hard to maintain. So we've gone ahead and re-architected that and came up with a 3-tag solution, which would also simplify our code in a number of other places. So our main tag is the item stack count, and this is the current count of items in this particular item instance. We also created a tag for the max stack count. It just became easier to pull these values off and use them for quick math than our previous design, which had them on the item icon fragment. And then we have a simple tag in storage, which should be either a 0 or a 1. The limitation of the set stat tags is that they're an integer value, which you can use as a boolean as long as you're careful and that you're adding and subtracting appropriately, so you don't ever get into a situation where I have a 2 or a -1. But so far, testing has indicated we've done that pretty good. The max stat count, as you can see on the right-hand side of the screen, you could set that to any number you want. So for an example, for our resources, we have them set to stacks of 200. But for currency, which is on the right-hand side, we have them stacked to 999. We could stack to 10,000. It doesn't matter. This is just to have the flexibility to be able to stack differently on different items. This would also be good for unlocking in-game things where you might say, look, the standard stack is 100, but if you buy a bonus pack from the marketplace, we'll increase your stack size to 200, 300, or 400, and you would just change these values in code. All right, so we'll see that in action as we start to explore some of the other classes. The other major thing we've done since the last video is completely refactored our inventory gameplay abilities. So if you remember, there are 6 abilities, the combined instances to push 2 stacks together, the drop into the world, the drop on the trash, which deletes, the move to storage, and the move back to standard from storage, and then the swap of 2 locations. What we were finding is that we were replicating chunks of code, repeatable chunks of code in each of those. And for maintenance purposes and modularity purposes, what we did is decided that we would move all of the functions on the right-hand side into the base class, which would allow us to just basically call and or override if necessary, but so far it's just been calling each of these blocks of code in sequence. And so the actual children classes script out the logic, but these are the major pieces of functionality that they use. And it's working a whole lot better. It's a lot cleaner. We can change something in one spot and have all the different actions occur. So with that, let's jump into the editor. And let's start by taking a look at it functioning. All right, so we launch into the world. I've got these rocks that are sitting here on the ground. I believe this is 150. I think this is 49. I think there are 200 in this one and 5 or 6 in this one. That's probably the wrong sequence. So at this point, our inventory is completely empty. So if we go pick up the first stack, you'll see I picked up 150. And if I go mine a node, 51, 52, 53, we have 153. I'll drop the 153 on the ground. Then I'll pick up 49, pick up 153, and I end up with 202, and it splits the stacks based on the 200 stack count. In this case, I'm going to now add to this 2. So if I went here and picked up 3 more, I should have 205, and I do. If I go into my inventory, let's move our 5 into the inventory stack, the storage bin. Go mine 3 more. So I should have 203. Go back here, put the 3 into the 5. I have 8. Oops. 208 in storage, nothing in inventory. Pick that one up. Forgot what that was, which was 6. Pick that one, which is a full stack of 200. I have 206. Go over here and pick up the logs. There are 5 individual logs here on the ground. So I should end up with 5 logs in inventory. Come back to storage. Now I'll swap the 5 logs with the 8 stone. 5 logs are here. 8 stones are here. Merge that with my 6. So I have 214. Move the 200 to storage. I'm down to 14. And as I grab 3 more, take my 17, drop them on the ground, pick them back up, and I have my 17. So you can see that whether I'm combining, swapping, adding to storage, removing from storage, picking up off the ground, or dropping, my stacks are doing as I'd expect. I hit a max stack count, it creates a new stack. Yeah, and so we're happy with the way that's functioning. We do still have to do the split, but let's take a look at a bit of the code. Let's look at ability. So this is the base of all of the inventory gameplay abilities. And it's not intended to actually be called, but it has all the various functions. And so some are very simple, like this broadcast, where we're basically broadcasting whether or not we're going to refresh either of the 2 inventory grids. And one thing you might notice, which might alarm some people, is that I didn't pull off of the storage pin. It's an interesting feature of functions over macros that you actually don't have to drag off of these, because any variables that come into your functions, you're automatically going to have a getter. So if this is cleaner for you, this gets standard, and this gets the storage variables. So you don't have to have lines everywhere. Functions will allow you to use any of the input variables as just standard getters inside that function. So we have things like getting our inventory manager, where we get our player controller from our actor info. We get our inventory management component. We do a variety of checks, and then we pass that back, either valid or not valid. We will do limit stacks. We'll do stuff like this, where we say, all right, if you pass in the max stack, the current count of the inventory item that you're trying to add to, and how many you're trying to add, it will basically do a little bit of pluses and minuses and compares, and respond back with an adjusted count. So it'll say, okay, here's how many you can actually store in it. So it's just a little function that helps us to drive some of those things. So each of these functions have their own components or own pieces, and then all of the, let's take a look at combine. So looks like I was doing some debugging here. Let's just take that out of there. And let's skip over that print string. Hopefully that's the only one. So we activate the ability. We parse our payload into our 2 items, our to and from items. We determine whether or not we're valid. We also give the option to commit the ability. So that's just a quick savings to be able to commit the ability early. If everything comes out of there successfully, we compare the 2 item definitions to make sure that they're the same. This is what we did. This is the code we added to make these blueprint accessibles. If the definitions are the same, we check to see if we're allowed to stack this item. And if we are allowed to stack the item, we say we are, and we give it the max stack. Here's where we pass in the current stack tag. So this is the new use of the item stack tag. And in here, I should have gone in here, we use our max stack tag. and basically say if the max stack tag is greater than 1, then you are stackable. So if it's a 0, i.e. the tag is not there, it's considered not stackable. If it's 1, it's considered not stackable. But if it's 2 or higher, it is stackable. I forget where I was. Oh, so I was in here. So we check whether we're allowed to stack. If that's true, we take our max stack. We get our current stack. We would do our request. And out of there comes our adjusted count, which may or may not be equal to our requested add. We add that to the 2 item, which will basically fill that stack to 100%, or if it was less than that, still less, but it might hit 100%. And then we check if our stack that we were taking from, we remove the exact same amount. So let's say that our stack was 100, but we only had room for 50. So this would come in as a request for 100. It would come out of here as 50. We would add 50 to the new stack. We would take 50 away from this original 100. And then we do a quick test to see if we have anything left. So if we have anything left, then we don't actually remove it. But if we're down to 0, then we can actually get the inventory manager and remove the instance from the inventory. That's it. We then broadcast our refresh and end our ability. So, use of the functions simplifies that dramatically. I'm not going to go into each and every one of the other ones. They all kind of do something generally the same. I will take a second in the drop because that is a little bit different. For the drop, we had to do a couple of things differently. So when we attempt to draw a spawn event, sorry, let's go back here. So when we attempt to drop into the world, we parse our payload using the same function that the others do. We determine whether or not we have authority and we're allowed to do that. We check if we're allowed to drop. We get our inventory manager. We go to spawn our new actor. So I'm going to come back here in a second, spawning the new actor. So this spawns what we're going to throw into the world or drop into the world. If that is all successful in this macro, then we're going to remove the item from the quick bar because it might have been a gun. And if it was a gun, we want the quick bar to deactivate. And we remove the item from our inventory, refresh our grids, and end. So most of the uniqueness is inside this spawn new actor, where the first thing we do is grab all of the attributes from the fragment. So the pickup class, particles, decay, lifespan, drop mesh, etc. These are all just pulls. They go directly into the spawn, expose on spawn variables. The unique part is how we establish the inventory payload and take advantage of the tags. So way back here, we're going to get our instance that we're dropping into the world. We're going to figure out how much inventory we need to have in this payload, and that payload is what we will assign to the spawned actor. In the establish inventory, it became very, very simple in that we grab the stack counter. So this is how many are active. We grab the item definition. What is this? We make a new pickup template. This is why we had to change it to become read-write. We make an array because the inventory items pick up an array. There's only going to be one template in here, but there could have been many. And that's our payload. So when we spawn a new actor, we compute how much inventory it's going to have. And that's why when we pick it back up, it has the exact same inventory counts. All right, on to picking it up, because this was another area where we had to do some significant changes. In the original interact collect, let's open this up first. So in the original interact collect, the Epic code basically takes a pickup. What's the easiest way to do this? You'll see here that the item is cast to a pickup type, and then the inventory is add from pickup. What that does is it creates a new item instance for everything you pick up. And that's why we were having multiple instances showing up and stacking wasn't working for us, right? So in the standard code, I can do this here. Off the inventory manager, there's add pickup to inventory. And that takes a pickup class. And so if you were to, that's a pickup class. If you were to take this, pass that to a pickup, and then pass this in. This basic logic generates a brand new instance for everything you pick up off the ground. And if you have 10 or 15 definitions in that, or 10 or 15 counts of a definition in that pickup, you're going to get 10 or 15 different item instances. So instead of that, seemingly simple logic, we had to basically blow that away. And we've created our own function. So this stuff is basically the same as everything else. We check that we are a pickup. We validate that the pickup is active, and then I'm able to pick it up. We disable any of the particle systems that are activated. We change collision. We turn off collision so that we can actually pick it up. We set the lifespan of the pickup actor so it basically expires out of the world after we're done with it. We send the gameplay queue to do the visual effects of it zooming up and into the character. And then if we have authority, we are performing our pickup on server. So here, we're using the get pickup inventory to extract the inventory out of the pickup. So we're taking what I think they call static inventory in the pickup actor and passing that into our function. And we're passing in the character that picked it up as well. And then if we're successful, we keep going. So let's go into this function because this is where all the logic to use the tags had to be written. In this function, the first thing we do with that character object is we get the inventory manager using the function. We make sure it's valid. We then break the pickup inventory, which is made up of instances and templates. Right now we're using 100% templates. There's a case that we might use instances later, but right now we're using 100% templates. For the instance array, we check if it's not empty. If it's not empty, we will process instances. Same thing for the templates. If it's not empty, we'll process templates and then basically exit return. So the process instances, an instance will include the stack count tag, the max stack count, and whether or not it's in storage. So those stat tags carry with the instance. So the instance is actually quite simple in that you just grab the array, you break the pickup instance array element, which is only one item in it, and you add that instance to your inventory. So this is a very simple. Instances go straight through, but as I said, we're not using instances. We're using the definitions because we want to be able to merge things together. All right, in the process templates, same process of getting the loop, breaking the template. In the case of the template, you get a stat count and you get the item definition. So rather than the item instance, which is an object reference, here you're getting an integer, which is how many. In our case, when we drop 150, the stat count will come back as 150. The item definition, which is the ID underscore whatever was dropped. So you take those two from the template, and we're doing our add stack by definition, which is another routine we had to write, which takes the inventory manager, the count of how many we want to add, and the definition that we want to add. From there, we're going to find the first available stack. And we'll come back into this in a second. But we need to find the first stack in inventory where we are not at the max stack limit, so that we might add some or all of the requested items into it. So for now, we're going to bypass that and realize, okay, we're going to get an instance out of that. If it's valid, which means there's at least room for one more on the stack, we'll follow this. We'll limit our stack. So we'll basically say, okay, what is the max stack? What is the current inventory? And how many are you requesting? We'll get back an adjusted quantity and a remainder. So basically the requested will spit out, if I request 20, I might get adjusted to 10 and remainder of 10. The 10 that will fit, we add. That will fill up the stack we found. And if I have a remainder, if there's leftover items to be processed, it's greater than 0, then I will generate a brand new item definition, which creates a new item instance from this definition with a stack count of 1. This creates this. The reason this is 2 steps is this stack count of 1 creates 1 item instance. If I put 2 here, I get 2 item instance. So we want to have 1 item instance, but then we want to go and update the stat tag associated with that item instance to the balance. So we're going to get 1 by default here. If I needed 10, I just take 1 off of that and add 9 more. So when I'm done these 2, I have 10. All right, if the find available came back with nothing available, which would be the case where I don't have any of this item yet, or I only have complete stacks and you need to create a new stack, then we'll follow the false path. We'll create the brand new stack just like we did on the other side. We'll take 1 off of that and we'll fill it up. So those are how we're managing the stack counts. And then in this routine, when we're trying to find the available stack, we first check that our inventory manager is valid. We clear the temporary working variable here. We get all the items from the inventory manager, and we do a little for each loop with break. So we're basically going to loop through all the items until we find one that meets our criteria. When it meets our criteria, we're basically going to come out here and pass that entry back. So in this case, if we met the criteria, we would have filled this value in, and we would have said it's valid. If we met no criteria, we would come back with an invalid. And those criteria are that the item definitions match. So as I go through the inventory, I'm looking first for one of the item definitions that match what I'm trying to add. Then I want to make sure it's not in storage, because I might have an item definition that matches, but it's in storage. That doesn't count when I'm out trying to pick up items in the world. I don't want them automatically added to my storage inventory. I want only items that are in my active inventory. And then I check to make sure I have some space left. And so if all 3 of those conditions are met, they're the same item definition, they're not in storage, and there is some space left, we'll populate that working variable, break the loop, exit out here, and pass it back. So all of that kind of replaces that very simple node of add this pickup to inventory so that our stacks can be processed as we're picking up and dropping things in the world and moving stuff in and out of our storage. So hopefully that completes this section of the or this chapter on the inventory and how to enhance the inventory, and then you picked up some ideas on how you might enhance the inventory yourself. Obviously, if you like the video, go ahead and give it a like, leave a comment. When we do the split stack, I'll post a very short video of that. But with that, we're going to move on to crafting, and it might take us a week or so to get the crafting systems up and running. So we look forward to feedback on all the videos so far. Thanks for watching.